Hi and good evening, everyone. Welcome to this webinar about Apache Kafka data enrichment using Kafka Connect and Kafka Streams. I'm Kobe and I will be your host today. I would like to begin by thanking you all for joining me in this time, and I hope you're all safe during the pandemic. And let's get started. I'm rather new in these technical streams and all that, so if I'm doing something wrong, please feel free to write me in the chat, and I'll try to correct it as I go. But I'm getting better at these at the technicalities of streaming, so I hope it will go better this time than the other time around. So welcome again. In today's industry, Kafka is the leading technology being used for data transport among services. Sometimes our data consumers are interested in knowing more about the data residing in Kafka topics than they have inside the Kafka messages themselves. For this purpose, we would usually need to enrich that data with data coming from external data sources. In this webinar, we will discuss several of the popular choices for doing exactly that, data enrichment. As we understand how each enrichment pattern is implemented, we will weight on several scales. The first scale will be the scale of programming flexibility. The second scale will be the scale of how much of a bottleneck the enrichment process can become in our data pipeline.
Record the meeting?
Oh yeah, it's being recorded and I'll upload it to my YouTube channel. Okay?
Sorry, thank you.
No problem. Okay, so the second scale will be the scale of how much of a bottleneck the enrichment process can become in our data pipeline. And the last scale will be the scale of code management and hosting. Stepping out of this webinar, you will have the knowledge required in order to create enriched data using Kafka ecosystem tools. All the demonstrated source code and slides will be available in the links I'll share on GitHub, and in my YouTube channel I'll post all the links and the slides, and that's it. Let's get started. Okay, so it all begins with a developer which reaches out to an API server and fetches some data. He then encapsulates the data in a message and passes it forward into a Kafka topic. This topic is being consumed by another developer, and she gets the message, and she would like to know how the data in this message relates to data stored in an external data source. She basically wants to activate an enrichment function having the input of the raw data she got from the topic she was consuming from, and she would like to produce a new message of enrichment data and pass the raw data together with the enrichment data together into a new topic. This slide describes what data enrichment in general looks like in the world of Kafka. We get a raw message, we activate an enrichment function on an external data source, and we pass the enriched message, which is made of the raw data and some enrichment data, together into a new message, which is an enriched message. So, the three scales for data enrichment, things we need to consider when implementing data enrichment in our data pipelines. So, the first scale will be coding flexibility. How easy is it for us, the developers, to create our enrichment function? What can we do in order to get the data and activate the amazing logic that our data analysts have asked of us, and create the enrichment data for our next step? The next scale for data enrichment is the data enrichment function overhead. How long does it take to receive a response for an enrichment request? What is the byte size of the response? And how much data do I have to scan in order to receive a response? And a lot of you guys who working with S3, for example, you do know that there are costs that are bound to scanning data. And so this is this is a very classic example of an overhead of an enrichment function which can be measured in actual dollars. And the last scale is the data enrichment hosting and management. Someone needs to host and manage the enrichment function and services that are getting the added data that we want. There are some more concerns which are related to the three scales of data enrichment, and they are: can we even pre-calculate the enrichment data? And we'll see how it relates to the samples, to the code samples that I'm going to demonstrate soon. Is it possible to clone the data source, the external data source, into a Kafka topic? Can we pay the network bandwidth overhead? And can we pay the storage overhead? And another question is, should the data enrichment process preserve message ordering? If we are now getting data from an external data source and fetching it back and creating new messages, which are the raw data and the enrichment data together, should we preserve the original raw data message ordering? So let's give it a try. The first attempt we're going to make on data enrichment is an on-the-fly data enrichment using a Kafka consumer and a Kafka producer. So in this example, we are going commando mode, and we basically are opening a Kafka consumer to receive a message from a topic, and inside this event, per each message that we are getting, then inside the event that we are now receiving, the event handler is making a call to an external data source, fetches some data, and produces an enriched message to the destination topic, to the enriched data topic. So in this case, we see that the simple application that we are writing is basically serving us as both the consumer and the enrichment function activator and the producer of the data. So rather simple, and I'll tell you a short statement about this method. This is the most common method today for data enrichment. Unfortunately, it's not the best, but it's the most common. So let's look at code. And as this is the first sample of code that we are seeing in this webinar, I want to direct you to my GitHub repo, and I'll have the link attached to the session and to the YouTube channel. But here it is in the general chat. You can go there now together with me. You don't have to, because I'm demonstrating everything. And what I'm going to do is clone this repo, which contains all the demos of this session. And we're going to build the demos. Now you're going to see that there's a README file here, so you don't have to remember everything. But basically all the steps that I'm going to do now are just to clone the repo, and then we're going to build a common image that I'm using throughout this session, and you can do it on your own. You can reuse that code freely. I'm giving it to the community as is. You can contribute to it, And now, all we have to do per each of the demos in this session, which are numbered as attempt 1 through 4. So in each one of those, we need to build to run a Docker Compose build before we are running the actual sample, and this will take care of everything you need in order to see the demo running locally on your machine. It will work on Windows and Mac and Linux, however you choose to do it. So okay, so let's begin. Throughout this demo, we are going to be using two data producers. The first data producer that we are going to use is the raw data Kafka producer. This producer generates data and places it into a Kafka topic. Okay, this is the raw data that we want to enrich. And then, it's basically just a simple Spring Boot application that every second generates a raw data message and passes it forward into the raw data topic, writes it as in the JSON format. What it has inside, in case you're wondering, is just one field called produceDate, and this field is populated before I send it with a simple date format, and I'm just writing the date and time in which this message was generated. So that's the raw data Kafka producer. We will use it throughout the demos. So I'm not gonna talk about it anymore. The second data producer that we have is the data the enrichment data that we want to write into an external data source. So the external data source that we are using, in this demo is Redis, and it was a request by one of the attendees, so I implemented it. And what it does is basically something very simple. I basically started a Spring Boot application, and then I'm establishing a connection to a Redis node, and this Redis is you will see it in each demo. You will see it in the Docker Compose. You will see that this Compose file brings up Zookeeper, Kafka, and Kafka Drop as a visualization tool for Kafka, and Redis, and also Redis Commander, and and also it will bring up the Kafka producer and the Redis enrichment data producer as well. So the enrichment data Redis producer is also something that we will use throughout this webinar. And what it does is every second, once per second, it goes to Redis. It fetches an atomic long called token ID. It takes this key and it increments its value by 1. So we expect to see that when we run this demo, we expect to see two things happening. From the aspect of the Redis enrichment data, we expect to see a token ID, which value is incremented by 1 each second. And on the Kafka side, we expect to see a message written into raw data topic, and we expect to see the value of it as in each message we will see a produced at in the value. We will see a produced at field with a simple date format in it, and we'll see it as we run the demos. Okay, so once we understood that we have these two guys, the Kafka producer produces the raw data, and the Redis producer producing the enrichment data. Let's now see the enrichment function as we implemented it in this first attempt. And it's basically an application that directs data enrichment it's an application, a Spring Boot application, which does all its magic inside an event handler called enrich and produce enriched message. So we are opening a Kafka consumer using the Kafka listener annotation of Spring Kafka. If you guys are familiar with it, you can. It's in the commando mode. You could use whatever you want. You could have just used a Kafka clients, the Maven dependency, and open a Kafka consumer. In this method, you could have used another programming language and do it. But this is the pattern. So the pattern says I'm opening a consumer on top of a topic. In our case, it's the raw data topic, and then every time that a message arrives at this topic, I'm going to Redis and I am reading the value of token ID, which is being incremented separately by the Redis enrichment data producer, and I'm reading the value, and then I'm creating a directly enriched message, which is just the class that I generated here, just for the sake of the sample, which has the original message copied, as the entire JSON is copied completely into the value, and as the data, I am storing the data that I read from Redis, the token ID value that I read from Redis. So what we expect to see is two separate pipes of data. One of them is creating data into Kafka, one is creating data into Redis, and then we will see that this application is running and creating a new topic enriched using direct Kafka consumer and Kafka producer, and inside of it we'll see the original raw data message as JSON and the value, the current value that was present in Redis at the time this message was consumed. So let's run this sample, and running each of the samples in the webinar is basically you are going to the Docker Compose file in the specific demo, and you just need to bring it up. Docker Compose up, you can do it manually or you can do it here, and what it does is basically deploying. It will deploy Zookeeper and Kafka. It will deploy the data producers, the enrichment producer, and it will bring up a visualization tool called Kafka Drop, and it will also bring up Redis and Redis Commander so that we can see the data flowing. So after this, let's see that the data is indeed flowing. And to all of you that are sending me in private messages about recording, I am recording. I'm recording it just using an external application, not using Zoom, for the sake of because I want a higher quality. Okay, so I'll share the recording on my YouTube channel. Okay, so I have Redis Commander here deployed, and you can see that the enrichment data is flowing into it. Just as I said, it's no magic. We have an application that reads the key token ID and increments its value once per second. And we have another tool here called Kaf Drop, and what it does is allows us to watch the data as it streams into Kafka, and we can see that the raw data messages indeed have the produced at field and a simple date time, but I want to see the enriched topic. I want to see the data that this application wrote to, and I expect to see an enriched using direct Kafka consumer and Kafka producer topic was created and indeed has the value of the raw data and the enrichment data. So let's go back and see if it's here, and we do see that the topic was created, and if we go to the messages, then we will see the original message field has the raw data as a JSON, because that's how I wrote it, and it has the data, and the data is the enrichment data from Redis. Okay, so first attempt, successful, but let's see how successful we were. So, okay, so this is what we've just done, and we've seen it plain. Let me just, before I continue, let me just stop this demo, compose down, so that in the next demo I won't have to make you guys wait. Okay, so let's talk about what we saw. So on-the-fly data enrichment considerations, the enrichment function is not limited. We did see this. Anything we can code can become an enrichment function. Everything we can put here can become an enrichment function. If I wanted to create, if I wanted to read the value of the token ID and multiply it by 2 divided by 4, I can do whatever I want. I could go and fetch a URI and count the HTTP links in it. I can do whatever I want. The enrichment function is not limited at all. Our enrichment function is a bottleneck, okay? And we see it very clearly. We see that while we are processing this event handler, no message can arrive at this method. Okay, because this annotation creates a trigger for an event handler. This is the event handler, and we are processing message by message. So as long as we are now reading, we are going into Redis, getting a message, and then we are converting to JSON, and then producing it back into Kafka. Then the message at back is waiting for us to finish, and we are basically the definition of a bottleneck. And we see that data enriching code hosting and management is required. In this case, I simply opened a process on my personal computer, but you can understand that for production, you won't leave this process running on your machine, and you will have to somehow manage the code and host it, and manage cases where it crashes and needs to be restarted, and all that goodies. Okay, so once we understood these limitations, so let's give it a try. Let's try again. So what we're going to do now is on-the-fly data enrichment using Kafka Connect. So in this case, we are going to get a message, and we want to apply an enrichment function on an external data source, and we do want to create an enriched message at the end of our pipeline, but this time we would like to host our enrichment code in Kafka Connect. So a few words about Kafka Connect before we begin, because some of you might not be so that familiar. I will just mention that I do have a full session about Kafka Connect, and I will link it also to this YouTube video at the end, so you could watch it if you want a deeper understanding on implementing connectors than the short description that I'm giving here. So Kafka Connect. Kafka Connect is the integration mechanism for Apache Kafka. Whenever you want to integrate data sources or data sinks with Kafka, the go-to mechanism should be Kafka Connect. It allows exporting data from a Kafka cluster into a third party, and it allows importing data from third party into a Kafka cluster. Kafka Connect is deployed as a distributed cluster of workers, and it exposes a REST API for management and configuration, and we will use it in the demos ahead. Work is done inside connector tasks, which are managed by the Connect cluster. Connector types in Kafka Connect are split to two. We have source connectors, which are responsible for importing data from a third-party data source into Kafka topics. And we have sync connectors, which are responsible for exporting data from Kafka topics into a third party. Let's look at code because too much slides won't cut it here. So, okay. Okay, so on our second attempt, we are still going to use the data producers. We are not going to use the direct data enrichment mechanism. And you will see it if you go into the compose file. You will see that this time we just have the raw data Kafka producer. We have the demo enrichment data Redis producer. And we have a Kafka Connect cluster. That's it. There is no application deployed here that is supposed to do the enrichment code, but we do need it. But we wanna have it hosted in Kafka Connect. So the way that we are doing it is by implementing a Redis enrichment fetching Kafka sync connector. So if we had here two types of connectors, we have source connectors and sync connectors, then why am I talking about a sync connector here? Well, let's think about it. What is my destination of the enrichment data? It's a Kafka topic, right? I want to create data and send it into a Kafka topic. That means that I need to implement a sync connector. I want to have something that listens on raw data and does something and then pushes data into a Kafka cluster. So that is the reason that we are using a sync connector. So our sync connector will look like this. And I will describe in very shortly, if anyone wants to see a thorough explanation about how to create connectors and a deeper dive, then I'll link the session. But in very general, a connector is an implementation of two classes. If we want to implement a Kafka Connect connector, then we need to, for a sync connector, we need to extend the sync connector class, and we need to extend the sync task. We need to extend a sync connector class and a sync task class. We need to provide the implementations for them, and that constitutes as a Kafka Connect connector. And compiling it correctly, we can hand it over to the Kafka Connect cluster. It has a configuration called plugin directory. I make sure that I compile it there, and the Docker Compose here makes sure that it's done correctly. So I compile it there, and then my Connect cluster knows how to instantiate this connector and how to distribute configuration to its tasks. That's a very high level explanation, and it's analogous to source tasks. So if I'm implementing a source connector, then I will extend the source task and the source connector, and not the sync task and the sync connector. Okay, so in our case, we are implementing a sync connector, and the sync connector first of all extends the sync connector class, and it has to do several things. First of all, it has to take care of configurations. What the metadata that we want to give the connector in order for it to be able to do its job. So the configurations that we are reading here are the Redis hostname, the Redis port, and the Kafka output topic name. Because per each message that we are reading, we want to be able to go to Redis, read the current value of the token ID, and produce an enriched message into the output topic name. So once the connector starts, I am overriding this message, this method from the sync connector. Once it starts, then I am reading the configuration. I am making sure that the configuration that was passed to me from the user is being stored locally in this connector instance, and then I am configuring the tasks of these of this connector, I have to tell the Kafka Connect what is the maximum number of tasks that I'm allowing this connector to run with, the degree of parallelism that I'm allowing for it, and I have to tell him that what configuration to pass to each task that I'm instantiating. So it's not enough that I'm telling him the degree of parallelism, but I'm also telling him what configuration to pass to each task so that the connector will work correctly. In my case, this connector is very simple. It's made to run in with one task, and it basically I'm passing it the Redis hostname, the Redis port, and the Kafka output topic name, and that's it. And once Kafka Connect instantiates a task for this connector, it will call the start method. And in the start method, what I've done is, as you might have expected, basically instantiate a Redis client, a Redis client which is used by a third-party library called Redis, and I'm instantiating it, and I'm telling him, hey, this is your Redis hostname, this is your Redis port. Please give me a client which I am holding as a member of this task. One more thing that I'm telling the task: please also create a Kafka producer and hold it. Be ready with it. So every time that I'm being called by Kafka Connect, every time that I'm getting messages from the raw data topic, I want you to do the following. I want you to go to Redis, get the token ID. I want you to create a Kafka Connect enriched message. This is a class that I created. All it contains is just as before. It contains the original message, the raw data message, and it contains the token ID as a string. So this code is very, very similar to the code you've seen before. The only difference is that if you'll notice here, you see that Kafka Connect can pass me a bunch of records. It can give me a batch, and I will have to do the iteration, the loop of the for each loop inside of it on my own. So what we are doing here is basically the same commando code that we implemented before, but this time inside a Kafka Connect connector, and passing it forward to Kafka Connect for hosting and management. And let's run this demo. Let's see it. It's running. Okay, so just as before, go into the specific demo folder and bringing up Docker Compose, and we see that it also brought up Kafka Connect here. And let's give it a second or two to stabilize, and we expect to see what we expect to see here is that this cluster is completely it was restarted and its data was pruned. So all we see here is that we have the raw data coming from the raw data producer that I mentioned before. It's coming with us throughout this entire session, and I see that I have messages being produced every second with a produce_stat value, and we see that it is being incremented. Okay, so, and we also see the data in Redis being incremented each second. So what we don't see is any enrichment data. Why is that? So this time we have to instantiate the connector on our own. We have to call Kafka Connect. And if you remember, then previously I mentioned that Kafka Connect has a REST API, and we need to call and tell Kafka Connect, hey, I want you to instantiate a connector with a specific configuration. But first of all, let's look at the cluster. So I'm invoking an HTTP GET request, and I'm sending it to my local cluster, to my Kafka Connect cluster, and he reports back, this is a Kafka Connect version 3, and here is your cluster ID. Let's look at the available connectors, and we see that we do have the Redis Enrichment Data Fetcher Kafka Sync connector here. This was done by this magic, the way that the connector arrived here. So it was done by a small trick that I did, and I just want to show you because you might wonder about it when you download the code locally. So basically, in my POM file, in my Maven, I have a Maven compiler plugin and Maven assembly plugin, and I'm telling him that when someone is doing a package request, please take the output of this project, of this connector, take the output and place it back in my Kafka Connect compiled connectors folder. And then when Kafka Connect comes up, then I am pointing at this folder as my plugin directory. So that's how my cluster knows about this connector that I've just showed you its code. So after we see that Kafka Connect recognizes our connector, we can go and tell Kafka Connect, I want you to deploy this connector. I want you to instantiate a connector with the following configuration. The name of the connector will be Redis Enrichment Data Fetcher Kafka Sync Connector. I want you to use the connector class with the same name. This is the class that we've implemented here. This is the connector class, and I want to tell Kafka Connect to instantiate it. I want to pass the value of tasks max as 1, meaning that my connector will run in a degree of parallelism of 1. I'm telling him also that the topics he should listen to are the raw data topic. I could have passed here a regex or a list of topics, but I want to listen on one topic. I want to listen on the raw data topic. The Redis hostname is Redis. The Redis port is 6379. And the output topic name, where to the place to write the enrichment data together with the raw data will be enriched using Kafka Connect. So let's post this request. We get a confirmation that it was sent correctly, and let's go to our user interface and see that indeed a topic was created, enriched using Kafka Connect, and we can see the messages in it, and the messages are the original message together with the token ID value at that time. Now, something interesting to notice. As you can see here, a lot of messages have the same token ID value, and that's because the enrichment process happened only once I instantiated the connector. So that's something to consider. If I jump to the next messages, let's jump to next message, and you'll see that this data was updated. So after the connector was instantiated, we do see that different values of token ID were passed to the next enriched messages. So the time of the instantiation of this connector matters because of the way I implemented the connector for this demo. So things to consider. Okay, so what we've seen here is that on-the-fly data enrichment using Kafka Connect has several considerations. The enrichment function is not limited. Again, anything we can code can become an enrichment function, just as we did in the commando mode. we simply had our code beautified and passed into the sync connector and sync task classes. We splitted it correctly and passed the code nicely into the put method. So we basically passed the code that we did before into a managed method, managed by Kafka Connect. Our enrichment function is still a bottleneck, meaning that even though we are now managing batches of messages by Kafka Connect, it passes batches of messages to us. We are still blocking. We are still we go to Redis per each message, so and asking for the current value. We are better on the term of code hosting and management, because we are now handing over code hosting and management into Kafka Connect, and we can bring down the cluster, we can bring it up, and we can parallelize the invocations. We can have a task max which is different than one to parallelize the process of enrichment, but then we will have to make sure that our configuration code is built correctly, so that our connector is suited for parallel running, which in this condition it's not. I see a question in the chat about why the Redis number didn't change in the second example. Well, it did eventually, and I mentioned it. It didn't change at the beginning because I instantiated the connector after accumulating a lot of messages, and then I had a big buffer of messages that pended enrichment, and they were all passed to the connector at the same time, and the value of the token didn't have time to change. They were all processed quickly, and then we saw that at some point, once we drained our buffer of accumulated messages, then the number started changing. And it started changing. By the way, why are you seeing that it's changing by jumps of 2? It's because this tool, Kafka Drop, demonstrates partitions separately, and then you'll see the numbers, the even and the odd numbers on different views. That's the reason. Okay, so we've seen another method for data enrichment. It's slightly better. We have our code managed in a Kafka Connect cluster. But can anything be done about our enrichment function posing a bottleneck? So it depends, and it depends on several aspects. The first one is, can we pre-calculate enrichment data? Is our raw data predictable at some degree? Can we think about what is going to happen? Can we foretell the future and know what we are going to be asked? In most cases, we can, to some extent, know what enrichment we will have to fetch, and if we can pre-calculate enrichment data, what is the overhead of writing the enrichment data to a Kafka topic? Storage overhead, bandwidth overhead, scanning the data in its original source, and all the things that I mentioned. If we answered yes to both these questions, then the answer is yes, there is something we can do. If not, then we need to consider scaling out our enrichment code. We need to make sure that we have more instances of our enrichment code that are running in parallel, and keep in mind that message ordering will not be guaranteed at all like this, and we will have to reorder messages if we care about the original ordering. And I guess that in most cases we do care about them. But let's focus on the yes. Let's focus on what to do if we can pre-calculate enrichment data and we can suffer the overhead of enrichment. And that's the next attempt. So this attempt is on-the-fly data enrichment using pre-calculated enrichment data using Kafka Connect and Kafka Streams. So let's describe the use case. So we have a message that comes into a Kafka topic. This is the raw data. We have a message coming from an external data source using Kafka Connect, written, this is the enrichment data, written into another topic. And we have a Kafka Streams application, which applies an enrichment function on both these messages, and produces an enriched message into a third Kafka topic. So a word about Kafka Streams. If you haven't used them before, then Kafka Streams is a client library which allows data manipulation for Kafka topics-based data. And it includes consuming data, transforming it, filtering, and producing data. Kafka Streams applications are basically built as topologies of processing nodes, and we have several types of nodes. The first one is source nodes, we have stream processor nodes, and we have sink nodes. Kafka Streams applications requires hosting and rely on a Java virtual machine. And for Kafka Streams, we have a DSL, a domain-specific language, which allows for the abstractions of data streams and data tables, and they are called K-stream and K-table. So before the demo, I see questions. Kafka Connect run on Kafka cluster or separate cluster? So Kafka Connect is a cluster, is a distributed technology on its own. It's shipped together with Kafka and distributed together with Kafka. But as a best practice, it's recommended to run a Kafka Connect cluster on its own. And though you can, it's basically a daemon you start, a process you start, and that constitutes a node. It's not a good practice to run it on the same cluster as you run your Kafka brokers, unless it's for development purposes or testing. Even in these demos, in the Docker Compose files, you see that I deploy them separately. I deploy Zookeeper separately, Kafka separately, and Kafka Connect separately. So that was a question from the chat. Okay, let's go back to the demo and let's see how to do data enrichment with Kafka Connect and Kafka Streams. Okay, so no one reminded me, but we need to take down the demo from before and go to our third demo. And before I start it, I want to show you something. So in this demo, we are not using the Redis enrichment fetching Kafka sync connector. We are completely decoupling any knowledge of Kafka and Redis and from a single connector, and we are introducing a Redis enrichment source connector. This connector is, as opposed to the previous connector we implemented, this time it's a source connector. Its purpose is to bring data from Redis, an external data source. And just like the sync connector we implemented before, we are now extending the source connector task, and we are extending the source task class. And just as before, the source connector class, the Redis enrichment source connector, which extends the source connector class, serves as a tool for configuration, and It just collects configuration information from the client and passes it forward into tasks by specifying task configs, and each of these configs is made of a Redis hostname, a Redis port, and a Kafka output topic name. And in the task itself, in the connector task, we see that again we have in the start, when Kafka Connect calls start on this task, then we are instantiating a Redis client, connecting to our Redis cluster, holding this connection, and now, as opposed to the sync connector in which we got messages in a put method, here it is our responsibility to poll on new data in the Redis cluster. So, Kafka Connect calls poll, and our code is invoked. So, each time Kafka Connect tells me, hey, check the source, see if it has new data, then I'm going to Redis and telling him, can you give me the value of the atomic long token ID? And then I'm taking this value and I'm taking the local date time as a simple date format, and I'm creating a JSON message and creating a Kafka source record. I am now passing a record to Kafka and writing it to the output topic name, which the user gave me as configuration. I'm taking this value and I am writing the enriched data, which is made of it is a class here, Redis enrichment data message. It has the value, the date in which I read the message from Redis, and it has the data, the value of the token. So I'm using this data as a message key, and then I am passing the enrichment data also as JSON, and it is the simple format date of the simple format date and the value of the token from Redis. So I'm combining it. I'm taking the date of from the raw data message, and I'm taking the token value from Redis, and I'm writing it into a new topic. So let's start this demo and see how it runs. And what do we expect to see once everything is up? So we basically we are still not doing anything, right? We need before we instantiate this connector using the REST API, the Kafka Connect REST API. All we expect to see is the raw data streaming into Kafka, but this time we also expect to see the enrichment data streaming into Kafka. So, okay, so just a sec. Okay, and after we get the raw data and the enrichment data into Kafka, is it enough? I'm not sure, because we still don't have the enriched messages the enriched messages are not written anywhere. So for that purpose, enter Kafka Streams, and this time we are doing the enrichment process by creating a Kafka Streams application. And this Kafka Streams application is very simple. It's basically a 20-liner, and what it does is the following. I am using a Kafka Streams builder to create a streams builder. I am giving it I'm now creating the topology of the Kafka Streams application. Remember that I mentioned that Kafka Streams applications are made of nodes. So I'm creating a node, first of all, a source node, which is the raw data stream. I'm creating a K stream on top of the raw data topic, which is produced by the raw data Kafka producer. So I'm reading the data and creating a source node, a Kafka Streams source node. It's a case made of type K stream, and it represents the raw data stream. Then I am creating another stream, another K stream, which is the raw enrichment data stream, which is created on top of the raw Redis enrichment data topic, which is populated by this new connector, by the Redis enrichment source connector. So, and at this point, we will have two streams of data. It's true that once I instantiate this connector, we will have two topics, but these topics are not enough for Kafka Streams to process it. We need to abstract K streams on top of these topics. So here we are creating the two K streams, and here the magic is happening. So at this point we are having a new K stream called enriched raw data stream, and it's a join. It's the raw data stream joined with the raw enrichment data stream, and it is joined on the key of these two streams. Now, the key in this stream is the produce stat value, if you remember from before, and the key of this stream is also the produce stat value of the messages in this topic. So we are combining them. We are creating a window of joining, a window of 1 minute, and all the messages from raw data stream joined with all the messages from the raw enrichment data stream on the key, on the message keys, where the message key is the same. Then, and in the sliding window of 1 minute, we'll generate an enriched message, which is a string, the raw data value, concatenated with the raw enrichment data value. And all this data finishes by being flushed into the enriched using Kafka Streams topic. Okay, so two new moving parts in this demo. We have a source connector to bring data from Redis and write it into Kafka, and we have a Kafka Streams application to perform the actual join of the raw data and the Redis enrichment data. So let's run this demo now. I actually did run it before. So let's see what we have here in Kafka drop. And we have the raw data streaming into the Kafka cluster, but I want also the data from Redis to arrive. So at this point here, just a sec. Okay, so this time we are instantiating a Redis enrichment source connector. We are listening on raw data just as before, and our output topic, and this is actually, I think, not relevant at all. It doesn't matter, we are not listening on the raw data topic, but we want to fetch data from Redis and write it into raw Redis enrichment data. Let's instantiate this connector. Okay, and now we expect to see another topic that was created, raw Redis enrichment data, and we see that the data, the redet from Redis, and the token ID, the token value, are written into the raw Redis enrichment data. What we also see is enriched using Kafka Streams. Our Kafka Streams application catches data from the raw data and the raw Redis enrichment data and writes values into the enriched using Kafka Streams. And we see that the enrichment process is now being done for us in Kafka Streams, and you see here that it's concatenated the value, the raw data value, with the enrichment data from Redis. Okay. So, nobody reminded me, so I'll remember on my own. Okay, so what we saw here is that the enrichment function is a little bit limited by the compliance to the Kafka Streams DSL, though it is flexible in the way that we can program into the framework, and we can implement Kafka Streams DSL supported facilities such as value joiners, and we can actually do more than the DSL originally allows us, but it is not as powerful as going completely commando mode and writing our enrichment function as we saw in the two previous demos. What we did see here is that our enrichment function is no longer a direct bottleneck. Our data is streaming into the system from into the raw data into Kafka, and then the enrichment data comes from the source connector that we implemented into Kafka, and the enrichment process itself is not bottlenecked. It's basically a join between two case streams, and they are always available in Kafka as persisted as topics. And we did see that Kafka Streams application, code hosting and management is required. So our Kafka Streams applications require a JVM in order to run. They are not self managed. In case a Kafka Streams application fails, then your enrichment pipeline will stop. And in case you need to do some scaling, then you will need to bring up your own instances, more instances, or take instances out of the equation, but it's not done automatically for you. So how can we avoid having to write and host Kafka Streams applications? Right, that we want to take care of the last scale of data enrichment. So unfortunately, someone should write and host the Kafka Streams code. Okay, we need someone to do it. And we do have several options for that. The first option is Lens's SQL. It's also called LSQL. And the second option is Confluent KSQL DB. Both tools are good, and I've used both of them. Both provide an SQL-like DSL. They are non-ANSI SQL compliant. It's very important to remember. Not everything you can do with SQL you can do with these tools. Lens's SQL has no free license plan that I am aware of. And Confluent KSQL DB offers a standalone free plan. And that's why we're going to look at KSQL DB. So KSQL DB creates a database abstraction on top of your Kafka topics. It allows for referencing your topics as streams or as tables. Just it's not a surprise to you guys, because you already know that these are the abstractions in the Kafka Streams DSL. KSQL DB can integrate with other data sources using Kafka Connect connectors, and it basically has an embedded mode in which you can embed. It will create a Kafka Connect cluster for you and instantiate. It will create a Kafka Connect cluster, not a real production grade deployment, but you can instantiate a Kafka Connect connector within KSQL DB server it's not recommended, but it can be done. So let's look at the attempt number 4. On the fly, data enrichment using pre-calculated enrichment data, utilizing Kafka Connect and Kafka Streams, but this time Kafka Streams is managed by KSQLDB. So again, we have raw data coming into our Kafka topics, and we have data coming from Redis using our source connector, and we have an enrichment function to apply on these messages, and we want the result to arrive at an enriched data topic. And this time we are going to have KSQLDB server manage our Kafka Streams applications. And let's see how it's done. So, going into our 4th attempt, what we expect to see deployed in this environment for this demo is again Kafka drop, Redis commander. We have the two familiar raw data Kafka producer, and we have the Redis enrichment data Redis producer, and we have Kafka Connect because we are going to instantiate our Redis enrichment source connector in it, and we have KSQLDB server. This time we do not have the Kafka Streams, the Kafka Streams based enrichment application, which goes and implements the Kafka Streams application on its own. This time we are going to do something different. Let's see what this something different looks like. So we are going to start the 4th demo. And let it stabilize. Okay. And we are going to start our Redis enrichment source connector because we want the data to come into our system. The Redis data come into our system. Let's go to Kafka drop and see what we have there. Okay, so what we have this time in Kafka drop is the raw data streaming into the system and the Redis enrichment data streaming into the system. Again, updated, and this is what we expected. Now, we want to have a Kafka Streams application, and we want to have a Kafka Streams application that takes the data from both these topics and creates a third topic for enrichment. Let's see how it's done here. So, we are going to connect to our KSQLDB server by using the KSQLDB CLI tool, and we are now connected to our KSQLDB server. And what we are going to do are the following. First of all, we are going to create a raw data stream, which is, and you see it's very similar to it looks very similar to SQL. It's not SQL, but it looks very similar to it. And we are telling KSQLDB server to create a stream called raw data stream with its key being produced at, and we want it to be built on top of the Kafka topic raw data, whose value format is JSON. Okay, so if we'll now see what we have in this stream by running a select star from raw data stream, and we are telling him show us the changes in the stream, then you are seeing that messages are being consumed by this stream and are presented to us. Every second we see another message with the key produced at, and just as expected. Now, we want to have another stream, just as we had in the previous application. We want to have a stream of Redis enrichment data stream, and we want its key to be the same as the raw data stream, because we want to do a join on them. And that's, Dori, I see your question there, and I didn't answer because the answer is here. In order to do a join on streams, we have to make sure that the key is the same, just as a join in between SQL tables. We need to make sure that the key is similar. So we are creating this Redis enrichment data stream, and we can see, let's look at the data there. And we see that we have in this enrichment data, we see that we have the produced at key, we have the read at value, read from Redis value, and we have the token ID as the data field in this stream. So all good now. And now we want to create the enriched data stream. This is the stream we care about the most, because this is the join. This is the stream that takes the data from the raw data from Kafka and the data from the enrichment data from Redis that was written into our topic, and we want to perform an inner join between these two streams with a window of 1 minute. Reminds you something? It's just like the application that we wrote before, but this time we are getting the code generated for us by KSQLDB server. So we want to create this stream, and here it is. So let's see if we do have any enriched data within this stream, and we see that we have the data updated every 1 second, because every 1 second we have raw data coming into our topic, and we see that the data was produced to Kafka at a specific time. We see that it was read from Redis at a specific time, and we see the token ID. So we got enriched data. Okay. So in this last attempt for today, we saw that our enrichment function was limited by compliance to Kafka Streams DSL and to KSQLDB DSL. We had to make sure that we write a statement that was familiar to KSQLDB's DSL and to Kafka, both and to Kafka Streams DSL. We noticed that our enrichment function does no longer pose a bottleneck, just with the previous attempt. And new to this attempt is that our data enriching, code hosting, and management was done by KSQLDB. We now handed over, we outsourced the task for managing our Kafka Streams applications code. So before I proceed, I see a question. Can you explain the windowing mechanism? So yes. Okay, so when we are dealing with constant streams of data, so a question can be asked about when we have a change log. We have one stream which is a change log, gets messages continuously. It could have started a week ago, and we have another stream which is constantly being updated with data on its own. So we are not talking about static data. So unlike SQL Server or a non-stream database, the data isn't static. So whenever we are doing a join operation, we have to mention the time frame in which this join is of interest to us, is relevant to us. Okay, Rotem, was it does it clear the issue? Rotem, feel free to unmute yourself.
Yeah, I understand that. I just I'm not sure about why did you choose 1 minute over 5 minutes or 10 seconds?
Sure. Just for demo's sake. In real life use cases, depending on your on the logic for data, it could be that your enrichment data is no longer of interest after 5 minutes, or it could be that you need a sliding window of 5 minutes to make sure that you aggregated enough messages to move forward with your enrichment process. It all depends on your use case. For demo's sake, 1 minute was sufficient. Okay.
Does it mean that you wait 1 minute basically?
No.
No, you don't batch them.
No. No. The Kafka Streams application, the topology is activated immediately upon a reception of a message in the source node. The topology begins to work. Okay. Mm-hmm. And it outputs data according to what it knows right now. Okay, if you said I'm looking for, I want you to take a look at data within a window of 5 minutes, then it will check to see that the new message, how it relates in terms of the Kafka Streams topology, how it relates to this new message. Okay, it only knows what it has now. It will never wait. There is no waiting.
Okay, thank you.
You're welcome. Okay, so after the 4 attempts, is this all we need to know about Kafka data enrichment? So I say no, but it's a start. What I've demonstrated here are the most common and popular use cases. Some of them are popular but not recommended, like the go in all commando mode, like attempt number 1 and attempt number 2. I don't recommend them, but they are very popular. So some resources for you guys to check out. Look at the official Kafka Streams documentation. It's rich. It's not rich enough, but it's rich. It will suffice for getting to start and working with the Kafka Streams and understanding things. What can be done, what can't be done, which facilities inside Kafka Streams I can extend. It's a good start. Several things to consider. The first thing is enrichment data caching. In some cases, we will want to use an external distributed cache and even prepare the enrichment data in it. We can put it in a data structure which will work better for us when we need to take the data out. We need to think about data ordering and reordering, because if we are running with a Kafka Connect connector, for example, and we are running in a specific degree of parallelism with more than one task, then we are basically risking messing with the original message ordering, and reordering will need to take place if message order is something that you care about. Think about exactly once. A lot of technologies and a lot of services tell you that we are giving you exactly once semantics, but the truth is that it's very difficult to achieve in a full data pipeline to preserve the exactly once semantics. It's very difficult because sometimes things that are that a specific technology manages are not managed by an external data source, and distributed locks and things that more complex patterns need to be implemented in order to really achieve exactly once. So I would say plan for idempotency and make sure your code knows how to be idempotent, and make sure that if you in the case that you've processed a message twice, nothing bad happened. And also be aware that data could be missing from your pipeline. And nobody shouted here, but I did plant a bug in this code, and nobody told me anything about it. But if you look here, then my poll interval happens every second, and I am polling data from Redis. But what happened if the data in Redis was updated in less than a second? What happened to the updates in between? So this is something to think about. Polling never guarantees that you didn't miss values in between. Think about it. Okay, and the last thing I want to say is that real time and real life together are online at best. So people guarantee our pipeline is real time, and even Kafka says that on the homepage it's a real time technology. It's not, because any technology and any data pipeline which relies on which gives the consumer the ability to control the rate in which it consumes data and passes data into enrichment functions and does all these things is at best online. At best, in the best scenario, we are doing it fast enough so that our users are not getting tired, but it's not considered real time, in which we count CPU opcodes and we know exactly when the message will happen. And in conclusion, in this session, we have covered that Apache Kafka data enrichment is the process of adding external data to messages we consume from a Kafka topic. And we've made several attempts at data enrichment. The first one was writing our own Kafka consumers and Kafka producers, the commando mode. And then we tried using Kafka Connect as an enrichment code hosting mechanism. And we understood that when our enrichment data can be prefetched, then using Kafka Connect as an enrichment data fetcher and Kafka Streams as an enrichment engine could be beneficial. And we've also looked at one way to abstract the usage of Kafka Streams, and in this case we did it with KSQLDB. Okay, so we did cover a lot, but there are more attempts. I could have gone on and on and on and improving on the solution. There are many things we can do to improve and secure our pipeline and make sure things happen faster, more efficiently. I do plan on making additional attempts, and feel free to follow me both on LinkedIn and on my YouTube channel. It's Kobe Hikri Software Simplifier. I will post these videos there with a link to the GitHub repo, and which has also the slides for this session. There are more videos there, and I will add more videos based on my free time. I'm doing it out of fun, and subscribe, follow me there, and let's do a short Q&A. Okay, a question. You mentioned Ktable. Can we load static data to Ktable, join it with stream data? Oh, yes, absolutely. So, as opposed to K-streams, K-tables represent the latest value in according to a key. So, we can do a join between K-stream and K-table, and it will also happen just as in this demo that we did a K-stream to a K-stream, but we could do a K-stream to K-table, and the stream will be joined. Any new message that arrives will be joined with static data in the K-table, but but it's not really static. All it means is that the k-table represents the last value according to a specific key. Okay, Dori? Is this clear? Okay. Any more questions? No questions, guys? Seriously? Am I that good? Okay, so...
it was great, thank you.
Thank you very much, Dori. So, in case no more questions, then I really, really appreciate your time. I will share this session with the community freely. Feel free to forward it to people, the recording, and thank you very much. I've had a great time, and I hope you did as well.
Thank you.
Thank you very much.
Okay, good night, everyone.
Bye-bye.